Greetings to everyone who is watching this presentation. The title of my talk is Origin of the Universe, Chance or Intelligent Design. When we look at the universe, we see that it isn't unstructured, isn't chaotic. We see planets, stars, star clusters, and galaxies. Galaxies form the clusters and superclusters which form the basis of the large-scale structure of the universe. We can see complex structures in the universe. All this leads us to the question, why the universe is not chaotic, unstructured? In general, there are two possible explanations, and these explanations contradict each other. One of them is chance, or accident, and second is intelligent design. These two explanations also form a basis for two opposing worldviews called evolutionism and creationism. What consequences can we expect from these worldviews? In evolutionism, the universe was appeared by chance, accident, and we shouldn't see any evidence of intelligent design. In contrast, creationism tells us that the universe was created by the intelligence, so there should be many traces of intelligent design. The question is, which worldview corresponds better to the known scientific facts? The main theory which describes the origin and cosmological evolution of the universe in the modern science is a Big Bang theory. On this picture you can see the main stages of the universe life in this theory. The Big Bang itself, rapid inflation, origin of the cosmic microwave background when the matter and light were separated, dark ages when there were no sources of visible light, formation of the first stars, which were the sources of the chemical elements heavier than helium, formation of the galaxies, planets, etc. But conventional wisdom tells us that explosions can't be the sources of increasing complexity. Explosions lead to the chaos. But there is one exception, and it is the case when explosion is tuned very precisely to do the right job. Does this fine-tuning exist in the universe? It really does. The strength of the laws of physics is determined by the relatively small number of so-called fundamental constants. You can see two examples of such constants in the equations below. First is the gravitational constant. It is a capital G on the left equation, which describes the gravitational force between the two masses, m1 and m2. Located at a distance of r from each other. Second is the speed of light, c, in the famous Einstein equation between energy and mass on the right. As we can see, in both cases there is a strong dependence between the values of the fundamental constants and the strength of the corresponding law. The word fundamental means that these constants cannot be derived from any other laws. Their numerical values are given from above, and we can only measure them experimentally. The strong dependence of the laws of nature from the fundamental constant values raises the very important question. Is the structure of the universe stable to variation in fundamental constants? Is the equilibrium of the universe stable or unstable to these variations? On the picture at the top of this slide, you can see two kinds of equilibrium. Case 1 is a stable equilibrium, like a ball on the bottom of the pit. If we push the ball to either side, it will return to the original position. And if it is the case with the universe, changing the fundamental constants by a small amount will not significantly change the universe structure. Case 2 is a non-stable equilibrium, like a ball on top of the hill. There is an equilibrium in this case, but it is unstable. If we push the ball to either side, it will fall and will not return to its original position. If this is the case with the universe, changing the fundamental constants by a small amount will cause a dramatic change in the universe structure. For a long time, scientists assumed that the structure of the universe is stable to the variations of these constants. But the result of the studies performed at the first half of the 20th century, which was unexpected for many scientists, was that our universe is very unstable to such variations. The numerical values of these fundamental constants are fine-tuned to provide the complex structure of the universe we see. I would like to present only several examples of this fine-tuning, which are the origin of carbon, relationship between gravitational and electromagnetic forces, masses of the proton and neutron, and strong interactions and proton-proton reaction. And the last example will be Earth in a habitable zone of the Sun. First is the origin of carbon. Carbon is a stable element forming the chemical framework of life on Earth. It is the basis of all organic molecules. It turns out that its existence is a result of amazing coincidence, fine-tune of the so-called nuclear resonance, which makes possible the formation of carbon in thermonuclear reactions, triple helium reaction, in the star cores. This reaction starts when two alpha particles, nuclei of the helium atoms, fuse with each other and form the beryllium nucleus. In common conditions, the collision of this beryllium nucleus with the other alpha particle would not lead to the fusion reaction. Particles just bounce off each other. But in a very narrow interval of particles' energy, the nuclear resonance would occur, which leads to the fusion reaction and birth of carbon. And you know what? The energies inside the star cores are just what are needed for triple helium reaction to occur. Moreover, the other reaction is also possible. Nuclear fusion between the newborn carbon nucleus and another helium nucleus, which leads to the formation of oxygen. But in this case, the nuclear resonance occurs at slightly lower than necessary energy level, which suppresses the reaction and preserves carbon. It was calculated that if the resonant level of carbon were just 4% lower, or the resonant level of oxygen were just 1% higher, there would be no carbon in the universe in the framework of the Big Bang. Is it just coincidence? Famous astrophysicist who positioned himself as an agnostic, Fred Hoyle, wrote about this coincidence. If you wanted to produce carbon and oxygen in roughly equal quantities by stellar nucleosynthesis, there are the two levels you would have to fix, and your fixing would have to be just about where these levels are actually found to be. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as chemistry and biology, and that there are no blind forces worth speaking about in nature. Second example is a relationship between gravitational and electromagnetic forces. Electromagnetic force is 10 power 40 times bigger than the force of gravity. The ratio between the gravitational and electromagnetic forces, which is 10 power minus 40, is tiny, but plays a very important part in the life of stars. If this ratio were less, all stars would be red dwarfs. If this ratio were bigger, all stars would be blue giants. In either case, it would lead to the absence of sun-like stars in the universe. Next example of fine-tuning is the fine-tuning of the masses of proton and neutron. Protons and neutrons are the building blocks of any atomic nucleus, except a hydrogen nucleus which contains only one proton and no neutrons. The masses of the proton and neutron can also be regarded as the fundamental constants. The relationship between them makes possible the existence of all chemical elements in the universe. If the mass of a neutron were just 1% higher, less than 1% higher than its actual value, neutrons inside the atomic nuclei of most chemical elements would be unstable. If the mass of a proton were just 0.2% higher than its present value, protons would be unstable and the existence of hydrogen would be impossible. The same is true if the masses were lower. Thus, both increasing and decreasing these masses would result in the absence of chemical elements in the universe. Next example is strong interaction and proton-proton reaction. It turns out that the possibility of proton-proton nuclear reaction, which is the main source of the sun's energy, strongly depends on the strength of the strong nuclear interaction. The strong nuclear force binds the proton and neutron together in atomic nucleus. Here is a picture which shows the proton-proton reaction. Two protons make a deuterium nucleus which interacts with additional proton and makes helium-3. Interaction with an additional helium-3 nucleus produces the helium-4 or conventional helium. If the strong force was a little, just 5% smaller, it would lead to the absence of deuterium, so the proton-proton reaction would stop at the first stage. If the strong force was a little, just 2% bigger, it would lead to the existence of diproton, the bound states of the two protons. And in this case, the first part of the proton-proton reaction would proceed unimaginably faster, 10 power 18 times faster, which would lead to the starless universe and at the present time. Stars were burned out completely during the very short period of time. The last example I would like to show is simpler, and it is connected with our own planet. We are very lucky to live on a planet which is located on the habitable zone of our star, the Sun. Habitable zone is the zone in the planetary system where water can exist in a liquid state, which is crucial for the existence of life. If the radius of the Earth's orbit or the luminosity of the Sun were slightly different, life on Earth would be impossible. We have considered only several examples of fine-tuning of the universe, but there are many more such examples. Who or what is responsible for this fine-tuning? In general, there are two possible answers to this question. It was made by chance or by purpose. If the former is true, we can estimate the probability of such fine-tuning event occurring just by chance. The probability that this fine-tuning event will happen simply by accident is estimated. One of the estimation is 10 power minus 10 power 123. This number is indescribably small and simply means nothing or impossible. So the fine-tuning of the universe couldn't occur just by chance. The probability of this chance is simply zero. Thus, we have to seriously consider the intelligent design and the great intelligence behind it. As Fred Hoyle wrote once, a common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics as well as chemistry and biology, and that there are no blind forces worth speaking about in nature. I think we have seen today that he had the very good reasons to write this phrase. Maybe it's time for all of us to pay a very close attention to the first phrase in the Bible. In the beginning, God created the heavens and the earth. Thank you for your attention.